Okay, I'm back. So my daughter is 2, and she was watching Wild Kratts, and she didn't want to stop watching to eat Daddy's delicious dinner. So that was what the crying was about. But I've also just now had some delicious dinner, and I'm excited to be back talking with you about averages, right? So you know how to calculate an average. But here's how it's written in statisticalese or statistics language. So X bar, which is just the symbol that means arithmetic mean or average. So we have 23 people in this class, and if we wanted to know what the average year that folks were born, we would add up all the years and we would divide it by 23, and we'd get the average year. And the way this is shown is that capital sigma is the summation sign. So it means we're going to sum. It means you're going to add. Okay, so that capital sigma means add. And X's usually denote the data that you're talking about. Okay, and so and then you put a subscript for an I to count off the number of people. So let's say if you go back, let's go back to slide 11 for a second, right? That has the list that everyone was born. If we were going to number everyone and then using the X notation, then the person born in 1962 would be X sub 1 or X1. The person born in 1963 would be X2. The person born in 1964 would be X3. The person born in 1971 would be X4. You see what I'm doing? And we would go, if we were to label everyone in this way, but our youngest class member who was born in 1995 would be X23 because there are 23 people in our class. Or N, capital N is used to denote the number of people in your sample. In our class, N equals 23. So we would add up the value for person X1 plus the value for person X2 plus the value for person X3 and so on. The year for X4 plus the year for X5 and so on. Right? And now let's go back to slide 13. So this basically says you're going to go from you're going to add the summation, right? So it's add from X1 to Xn all the way up to Xn, and N, there are 23 people in our class, is 23. And then divide by the number of people in our class, which is 23. Okay, so you know that, divide by the total. And so that's, you already know how to do average. That's just how it looks in statistics language. And it's going to be our most commonly used statistic. In fact, I would argue that even some of our more complicated statistics that we're going to get into later in the semester, basically we're talking about averages. Sometimes we're talking about weighted averages, but it's basically all about averages. Okay, slide 14. In Excel, you can calculate it similar to our X bar equation, where you write sum, you tell the command is to sum the cells in a particular range, and you divide it, and that's shown. I'm trying to reverse my actions so it looks right on the video. You divide it by the count of whatever range of cells that you are doing your calculation from. Or you use the function, the shortcut function average, and then you just put the range like D2 to D24 inside the parentheses. And again, when we do this, it'll be much clearer. So I'm going to go a little bit fast. So if I were going to find the mean height of the class, I would use n equals 23 or count the height. The sum of the height, you see in statistical language, it's that summation sign, it's that sigma. And in Excel, it's SUM for sum. X bar is the sum of height divided by n, or X bar is SUM of height divided by the count of how many people's heights you measured. And then you could figure out the average height of members of our class, and if you you could go back, convert it back from inches to feet and inches. Okay, so slide 16, advantages of the mean. It's the most commonly used statistic. It's easily manipulated algebraically, and it's good for computing other statistics, which is why it's so prevalent. Disadvantages are it's too easily influenced by extreme scores. Okay, so you know how that happens when most of the students in a particular class do well on a test, and then you have a few students who do really badly. It really pulls down the average score for that class. It doesn't represent skewed or the multimodal nature of some distribution. So if you have a clump of high scores and a clump of low scores, well, your mean is going to be in the middle, and you wouldn't know unless you looked at the distribution that actually it's not that most people scored in the middle. It's that there were a group of people who scored very well and a group of people who scored very low. And finally, it requires some faith in the interval properties of measurement. So it's best with continuous data. It's it doesn't work so well when your data is not continuous, or it's not like kind of the regular things we would expect where there's an equal distance between each value of something. There's an equal interval. It does best when there's an equal interval in your scale of measurement. Okay, so how do we know which measure to use? If the data is interval or ratio, so continuous with or without a zero value that is meaningful. If it's symmetrical, if it has a single peak, the mean is the least biased estimator of the population. Okay, and so you check it first, use the mean if you can. If the data is ordinal or it's skewed, the median is preferred. So if it's categorical ordinal, you kind of want to, and the median is probably where you're going to, is what people mean by the typical value. Use the mode only if the data is nominal or your question specifically asks for the most frequent value. So when we were talking about our colors of M&Ms, that's nominal data, it would have been very appropriate to use the mode. You can't really compute an average of colors. All right, so which measure would you, I'm on slide 19 now, which measure would you use if you wanted to discuss the performance on the next class test? Usually tests are scored with continuous measures, and so you would probably average. Most tests, the average is the mean, arithmetic mean is the type of central value you would use. Here's another question. For USC graduate students, what measure of average income is most appropriate? Okay, would you use the mean? Why or why not? If I wanted for graduate students, let's see. So a lot of graduate students, many of them are working, so some of them may not be, but some of them may not be. Some of you are in very lucrative fields and you're doing quite well in your chosen profession. Some of you are doing quite well in your chosen profession, but you're in a less lucrative field. So if we have graduate students, that's going to include students at the med school, students at the law school, students at the School of Education. So if we wanted to know what the typical income was I wouldn't use the arithmetic mean, because I think it would be too influenced by extremely high or extremely low values. So I would probably use the median as to get a sense of what the typical income is for graduate student, USD graduate students. So the median, it wouldn't have those students, graduate students who are going to graduate school full-time and don't have any income right now. Their incomes of 0 would not pull down our average income if we use the median, and it would if we used the arithmetic mean. Okay, so and on the other side, though, for those students who are CEOs and CFOs of this or that, or junior partners or whatever it is that they're doing that's very lucrative, but their lifestyle does not reflect most of the graduate students. The median would make sure that their incomes did not pull our measure of the typical income too far up. All right, so that's it for central tendency, and next we're going to be talking about variability. So see you next time.